So hello everyone, this is a video on Cadillac Turbo 400 cases. So all of my vehicles I have are predominantly 472 or 500 Cadillac engines. Okay, the two cases closest here are the start of production for the 472. This is a 68. This is a 76 from behind a 76 model 500. Now, the thing to note here, these are a Buick Olds Pontiac bell housing. The same 77 through, I forget when Cadillac quit using the 368 motor, but the later 425 or 368s also will use these bells. Now, also 65 through 67 utilize the flat bell, like this case. Now, there are some 64s, and I actually have, through a lot of parts I bought from a gentleman a while ago, had a 64 Cadillac that had a adapter plate to a round bell like the early Buick 400s. So that's a different story, but for the sake of this video, this is a 65 through 67 case, which would have been behind a 429. These two 472 started production, 500 the last style like that, but they will work in the later years. Now, these all have the very super long output. So here is a tail housing off the 65 through 68, I'm sorry, 65 through 76 I've done, had the long tail housing. Now, there is a difference on the earlier units because they take a 350 seal and bushing versus 400 like this is. So, at any rate, the purpose and the reason I started looking into this, there's a lot of 400 cases over the years, and there's a lot of subtle differences. Basically, same everything. So, I made notes because there's actually a lot that I've researched here, and I never really paid attention until a project, which this is the first video of this project. So, this case here was out of a 66 Cadillac with a 429 that had the switch pitch. So it had the stator and the converter that would change angle and all that. This case is bad. It got hot enough, it actually ruined the back part of the case due to no lube. So there's that to keep in mind. So I had an early and a late case, and I was trying to decide which one to be best, comparable to the early 67 switch pitch. And what I'm doing is taking a regular 400 and converting it to a switch pitch, which is possible. So, things to note about the different cases. Okay, most of the Cadillacs, because of the engine size, the torque, and the weight of the vehicle, are considered a heavy-duty case. So you have strengthening ridges in the bell housing, especially in the ear area. The thickness of the case itself, especially at the flange of the pan, is very, very thick versus the earlier ones are the light duty. So you have that. They all had these strengthening ridges. Also, when you pull the pan, not all 400s had the strengthening ridges there, and I'll show this closer in detail in a bit. So that's the main differences. Bell is thicker, pan rail's thicker, strengthening ridges, reinforced ears. Something else to note, inside these cases where the center support lugs, some have all of the lugs in there, some are missing one or up to three. I never paid attention in my research. Wow, okay, I get it. All the Cadillac cases I have for the big block engines, the 472 500s, have all the center support lugs, reinforced, heavy duty, thick pan rail case around the ears and the bell, all of that. Other thing to note, 8 pump bolts. So all of mine, some of the later units don't utilize all 8 bolts, but they are there in the case. And again, I'll show this closer in a minute. Let me think here. Between early and late on the cases, there's only 2 casting differences that I have found. And I've looked at these till I'm blue in the face, so I'll show you that and we'll go through the other stuff here. So on the case, this is a 68. On the pump, they have this extra casting there just below where the overflow or breather tube is. In the early cases, it's metal on the breather tube. The laters, it's plastic. They do not have the extra ridge there. You can see that. It's got all the lugs, just like these. Now the difference, and you can see the extra ridges and everything there. This is where this... So if you look where the modulator passage is, this right here, this passage is where the governor circuit feeds back to the modulator. And you can see it's got a lot of casting there with a little hole, whereas the 76 model case does not have that. This is open all the way through. So there's that. Everything else is identical minus the extra casting there. Okay. Now this case, flat, now this is a 390 429. This is made for a 429 65 through 67. It is identical with the extra casting here and here. It is also identical as the governor to the modulator passage there as the 68. So that is something interesting to note there. They have the set screw for the center support, whereas the later 76, I forget what year they did away with it, does not. Now, this is where this gets interesting, because this is the first video of doing a conversion on a variable pitch or switch pitch from an original style unit. Now, I'll show you something very critical that when doing a conversion has to be done to the case. And it's so minute, it's ridiculous, but it makes like all the difference in the world. So, if you look in this original 66 case, right there, there is a little cut plug, and that is a .028 hole drilled in it. This is a non-switch 68 and a non-switch 76. It does not have it. So, let me find this bad boy and I'll show you. Doing research, a typical glass fuse, you break the glass, melt the solder out, the thing, of course you drill the .028 hole, and you can drive that down in. It's stepped from the factory, and of course when the pump goes in it can't back out anyhow. This is very critical. The reason this is very critical is this is line pressure from the pump, because the stator control solenoid at the pump dumps main line, and it allows it to shift and change to the high angle from low. That restricted orifice maintains line pressure at the modulator valve. So if that's not there, it does not work. So you take one of these, break it, melt the solder, drill the .028 hole, and you put it in that particular stator signal hole. So you can see glass fuse, and of course you'll have to drive it in, but that's where she inserts. Let's see, in the 76 case is right there. So basically, I was trying to do research and determine what would be the best route to go on these cases, and trying to determine if it's possible to convert one. So it is. You make a cut plug, drive it in the stator signal hole. They're the same other than the passage from the governor to the modulator, so you might have to play with governor weight or springs, which I'll determine when I get this thing assembled and in my vehicle. I'm using my 76 case because it's not damaged. This one has dowel pin hole broke. So the 68 is identical other than the bell pattern of the switch pitch unit I built for client 66 Caddy. So other than that, I'm thinking we can modify the governor, use a later 76 case, and I don't know when the change happened at that passage. I really don't. But we're going to hope for the best. So just specific to Caddy, that's what I know about these 400 cases and variances through that year span, okay? Chevrolet had a lot of variances. Buick had a lot of variances. There were round bells available and all. This is specifically a preliminary to explaining case variances between a non and switch pitch 400, and why I'm going to use the one I'm using. So I hope this information helps. There's been a lot of research involved on this, and I can't wait to get together to see how it works. So I'll do other videos on the process. I'll compare the pump and input drum and all that variances later, and I hope it's helpful. So like and subscribe. It's going to be an interesting build, and I will keep material fresh through the whole process. So thank you again, and thanks for watching.